In our lesson today, we are going to look at the Pythagorean Theorem, which has become a foundational theorem in geometry and is widely used in construction, architecture, navigation, surveying, electricity, and engineering fields, just to name a few. The theorem was developed by Pythagoras of Samos, who was an ancient Ionian Greek philosopher born in 570 BC. His work influenced the philosophies of Plato and Aristotle, as well as Copernicus and Isaac Newton. So let's take a look at his theorem. The Pythagorean theorem states that for a right triangle, the square of the two sides, referred to as A and B in the theorem, equals the square of the hypotenuse, the longest side across from the 90-degree angle, referred to as C in the theorem. Here is a picture of a right triangle with the sides and the hypotenuse labeled, and the showing of the right angle and how C is located across from it. The formula representing Pythagorean theorem is a squared plus b squared equals c squared. Let's take a look at how this works. Before we get started with the theorem, it is essential that you know how to square a number and how to find the square root of a number. The square of a number is expressed using an exponent of 2, such as 5 raised to the second power, or 5 squared. That means the number is multiplied by itself, so 5 squared equals 5 times 5, or 25. This is what it would look like on a scientific calculator on your iPhone. Here is the grid before you. You would put in your 5, and then you would find the key that's marked x squared and press it. And when you do, your answer will arrive, which is 25. Conversely, the square root of any number, say 25, is a number that can be multiplied by itself, and the result is the original number. So, the square root of 25, for example, would be 5, because 5 times 5 equals 25. This is what it would look like on your scientific calculator on your iPhone to calculate a square root. First, you would put in your value of 25. Then you would press the square root key, which is the key circled here. It's a 2 over top of a square root symbol with an x underneath it. And when you press that key, you will be given the answer, which is 5. Now that we know how to find the square and square root of a number, let's put the Pythagorean theorem into practice. Suppose we are told the length of a side A is 3, and the length of a side B is 4. What would be the length of side C? Here's how we would determine the value for C. First, let's substitute our values into the formula. 3 squared plus 4 squared equals c squared. At this point, we would put our values into the calculator and square them using the appropriate key, and we would find out that 3 squared, 3 times 3, is 9. 4 squared, 4 times 4 is 16. That gives us 9 plus 16 equals c squared. We would simplify our equation by adding 9 and 16 to get 25. So we have 25 equals c squared. Now to find the value for c, we have to take the square root of each side. So we put in 25 into our calculator, press the square root symbol, and we find out that 5 is equal to c. So the hypotenuse here is 5. Suppose we are told the length of side C is 5 and the length of side B is 4. What would be the length of side A? Here's how we would determine the value for A. First, let's substitute our values again back into the formula. So we have A squared plus 4 squared equals 5 squared. Again, we use our calculator to square our numbers, so we get A squared plus 16, which is 4 times 4, equals 25, which is 5 times 5. Here we're going to subtract 16 from both sides to isolate our variable a so that we can solve for it. That gives us a squared is equal to 9. Again, using the square root symbol for our calculator, we take and we find the square root of a squared, which is a, and the square root of 9, which is 3. In the construction field, the Pythagorean theorem is often referred to as the 3-4-5 method when working with squares and triangles. How would your calculations change if you were told the length of side C is the square root of 25 and the length of side B is 4, and you were asked to determine what would the length of side A be? The square root of 25 is 5. So again, we can use our calculator to figure this out. And then we just simply plug the numbers in and solve the equation. A squared plus 4 squared equals 5 squared. We're right back to the same problem. Using our calculator, we square our numbers to get 16 and 25. Again, subtracting 16 from both sides to isolate our variable a. We wind up with a squared equals 9. And again, taking the square for each of those values, we wind up with a is equal to 3. Let's take a quick look at a word problem. You are looking to buy a new smart TV. You found out that one has all the features that you want. Now you just need to figure out if it will fit in the spot on the wall where you want to put it, which is 50 inches wide. On the box it tells you the TV measures 60 inches diagonally and has a height of 30 inches. Will the TV fit on the wall where you want it to go? Let's start by taking and developing a picture in our mind, which we'll use here to illustrate how the triangle applies. So, we have a smart TV and we're drawing the triangle in place. That helps us to identify what's the A, B, and C sides. Here, we can see that A is on the left, B is on the base, and C is the hypotenuse. Now we have to just simply plug in the numbers. So we find out that A, which represents the height, is 30, and C, which represents the hypotenuse, is 60. And we'll be solving for B. Let's plug in the values and find out if that TV is going to fit. Plugging in our values, we get 30 squared plus B squared equals 60 squared. Again, taking our calculator and squaring our numbers, we get 900 plus B squared equals 3600. So subtracting 900 from both sides, we get B squared is equal to 2700. We take the square root of 2700 using our calculator, and we find the square root of B squared, which is B, and we find out that B is equal to 51.96. Sorry, doesn't quite fit. I missed it by that much.